My name is Manesh,
And I'm Sean.
and we are Team AA. And so our project consisted of an alcohol gas sensor, basically a breathalyzer. And the purpose of it is to notify the user if he or she is capable of operating a motor vehicle after a few drinks. So first off, just going to give an overview of it. So we ordered the MQ.3 from sparkfun.com. It's like $5, it's pretty cheap. So the device is a breathalyzer, which, like I said, can be used to measure the BAC of an individual. Some new hardware that we used was the MQ.3, which converted the analog to digital. The LCD was used to display the BAC level. LEDs were used to assist the user in loading into the sensor, and button 0 was used to initiate the cycle. So specifically, upon startup, it'll just read breathalyzer, and then as soon as the user pushes the button 0, it will start counting down. And while it's counting down, it's calibrating. We'll talk about more about that later. But it's counting down from 5 to 0, and then upon hitting 0, it hits start. And then this is when the user blows into the sensor for the duration that the 8 LEDs are lit. And then as soon as the 8 LEDs are lit, it'll display on the LCD, the BAC level.
Alright, so here's our hardware design. It's very similar to like all the components we used in Microblaze. Was very similar to the function generator. The only difference really was using the SPI to communicate with the 81 instead of DAC, and we used the MISO for that. We have the GPIOs communicating with the LEDs, the LCD, and the button 0. We used 380K resistors to kind of limit the voltage going into the 81. And let's see, then the software, upon power up, we just initialized the LCD, and then this is where it would display the breathalyzer, and then once you push the button, it'll start the sequence of, calibrating and calculating the milligrams per liter of alcohol it's detecting, and then from there it'll calculate the BAC and display it on the LCD. And here it'll just hold until you reset again, or to calculate the new BAC.
So like this whole software process is when the LEDs are being played. So that's what it's doing while you're blowing into it.
Okay, so the alcohol sensor requires a 5-volt supply to have it running, and it also requires a burn-in time, which is while it's getting the 5-volt supply, it'll heat up and then cool down until it reaches a stable point, and at that point it's most accurate. So we found the burn-in time to be about 6 hours. Like over a period of 6 hours, it took to become very stable, so we get very accurate readings. And then we used 180 kilo ohm resistors to prevent the voltage from exceeding the 3.3 volts that the A to D could handle. And the A to D converts the voltage being sent into the Nexus board to a hexadecimal value, where we could use that to calculate the BAC level. So our functions really, basically for the software, one of the most important things to get running was reading from the DAC, so we made a function DAC read, and probably the trickiest part about this was we had to send a message to the DAC to get a clock cycle going so that we were able to read from it. Thanks to Greg for helping us with that one.
Basically, we wrote nothing to it so that we could actually read from it.
Right. And then we just had a simple convert the hexadecimal to BAC, and we did this, calibrating with an actual breathalyzer. So we would blow into it, and depending on what BAC that breathalyzer would give us, we would read the voltage off that and just kind of calibrated it from there. Integration and testing probably the funnest part about this project.
Well, I mean, at the beginning, we just wanted to get the ADC working properly. So in order to test for that, we just set a voltage, a bearing voltage, to the Nexus board and reading it out on the LCD. Once that was working, it was just dealing with the sensor and tweaking that.
Yeah. So we have the sensor connected to the breadboard, and you know, it goes to the resistors and then into the A to D. Yeah. So again, with the preheat issues that we had earlier, before it got to the 6-hour mark of preheating, it would jump sporadically to higher voltages or lower, so we weren't able to properly calibrate it.
The results were like all over the place, so we had to make sure it was consistent heat before
Right. Let's see, then once we connected everything together, we started using alcohol on our breath. We used mouthwash as well as you know, doing shots of Captain Morgan. So yeah, we found that just using one, what was it, like just 50 milliliters of mouthwash and rinsing that in your mouth and then spitting it out, you can get the sensor up to, you know, 0.08 for actual DUI.
I mean,
So
it wears off quickly. Yeah.
Yeah.
You can blow 0.08.
So due to the sensitivity of the gas meter, we decided to limit it at 0.08 at the DUI level and not go above that for measuring your VAC. And yeah. Anything else? Questions? Any questions?
Did you know about the burn-in rate?
Yeah, it was on the data sheet.
But on the data sheet, it said greater than 24 hours, and we were not going to burn it for 24 hours, so we did it for 6. As long as it stopped getting hot and cold.
What did you guys use to test it?
Mouthwash and Captain Morgan.
Did y'all start, okay, so y'all also use like actual liquor or alcohol?
Yeah, we did. Yeah, like we would take a shot of, you know, Captain Morgan, swish it around for a good like 30 seconds, and then
It's actually not that bad.
yeah, it wasn't that bad. Yeah. So then we have a demo set up over here that we'll show you guys how it reads. So we brought mouthwash to test it out. Manesh will do the honors.
Okay, so you want to...
Yeah. So there's just a load up. It reads breathalyzer, and it'll just hold it in this state until we're ready to go. And once we push button 0, that's while it's counting down from the 5 down to start. It's actually calibrating. It's measuring the gas around it so that it has some sort of basis before the alcohol is added in, and then it subtracts those values to get the value of just the alcohol.
So, DUI.
So I got it up
If we
to-
wait like a minute, I could probably get it down to like 0.04, 0.06. It wears off really quick, but DUI, so I'm probably blowing a 0.08 right now.
Yeah.
I shouldn't have.
So we shouldn't drink mouthwash?
Any more questions?
And the mouthwash is only what, like 5% alcohol. So I mean, if you're taking like 40% alcohol and swishing that around for a while, we get up to, I think we got up to like 0.12 or something like that.
That would hurt.
Yeah.
So I'm 0.09. So, and this is a
It's pretty
legitimate
accurate,
sensor.
yeah.
So, yeah, I definitely can't operate a motor vehicle at this moment.
Really?
Oh, and also there's a cool down period for it too, because if I were to, if you keep running it, it's gonna keep showing it for like I think a minute or two, and then it'll get back down to 0, and then you can use it again.
That's
So there
from-
is a cool down period.
From the alcohol just staying in the screen of the sensor.
Caught up in it, so.
Yeah.
So that's actually the right there.
What's that?
This is actually the
Oh, that's the sensor.
Yeah, that's the sensor right there.
So
yeah.
that's the 5 volts going in, and then this is the.
That's a commercial product.
This is a,
Yes.
yeah. This is a real. I guess the real one, yeah. But